C8502 Structural Analysis 1 Restrained Structures in Stiffness Method prepared by Anand A. Assistant Professor, Civil Engineering Department, Rohini College of Engineering and Technology. Stiffness Method. So introduction. Stiffness method is the more popular younger brother of flexibility method. Although the two methods are the opposites to each other, they are akin to each other in several respects. Like in flexibility method, this also involves generating elements matrices, assembling them to get the system matrix, and inverting the same to solve for nodal displacements, members displacements, and member forces. In the solution of the structure, the important result in the member forces displacements are generally of lesser importance. However, in stiffness method, we get to the displacement first and then to the member forces. And next, properties of the stiffness matrix. So it is a symmetric matrix and the sum of elements in any columns must be equal to 0. It is an unstable element, therefore the determinant is equal to 0. The given indeterminate structure is first made kinematically determinacy introducing constraint the nodes. So this result in stress resultant discontinuities at these nodes under the action of applied loads, or in other words the clamped joints are not in equilibrium. Restrained structures. In the flexibility methods, the difficulty of solving a structure increases with the static indeterminacy of the structures. In stiffness methods, the difficulty increases with its kinematic indeterminacy. Thus, structures with more constraints, supports are more easily solved than structures with more freedom will appear. The structure is easier to tackle than the structure. Thus, we have to get familiar with kinematic indeterminacies of freedom. So, this is the restrained structures in the portal rigid frames. Due to the action of forces, there will be a rotations, moments. It will be in restrained in that structures. So, in this element and global stiffness matrices, local coordinates. In this analysis, for convenience, we fix the element coordinates with the member axis called element or local coordinates. Next one, global coordinates. It is normally necessary to define a coordinate system dealing with the entire structure is called system on global coordinates.